Welcome back to Balvigan Bharti with your mentor Avilash Sarkar. As you know, we have already started a new chapter, that is binomial theory. So, in binomial theory, we already expressed what is binomial. Binomial is adding two different terms. So this is the binomial, and the binomial theory, if I define this is binomial, and theory is a method of expanding a binomial of any finite power. So that means if I say x plus y is a binomial and raised power of n, where n is belongs to the natural number, integer and real, and in this case for finite series, because we will study on the finite series, n could also be negative, but that will be a different kind of series will come if it is n is negative, but whereas we will study for n is positive. Okay, so these are the conditions where if I expand this series, I will get an expression, and that is being studied in a binomial theory, and the method that is used to expand it is called the binomial theory. So binomial theory is the method by which we can expand a binomial with a finite power of the whole, and the expression that I will get by this method is the binomial. It comes under binomial theory. So this is the basic definition of binomial theory. Now, to understand that, if I go with the basic concept of expansion, the extent of that we already know. How do you know? Because if I say a binomial of x plus 1 whole power 1, that will give you these two term only. Where? Okay, and this coefficient is 1 into 1x into 1y. Okay, further, to our knowledge, we can extend it, the x plus y whole square, as 2xy plus y square, where we can write this, or the up to certain extent, up to the whole cube, we already we are using in our algebra, where we use it as a formula. Okay, x plus y whole cube or a plus b whole cube, that formula up to this extent we already using directly. Now if we analyze this is giving this coefficients, and another observation, one or two observations already you can see, if you see it properly, is that the power of the first term, this is first term, this is second term, power of the first term started the power of the terms varying from highest power to the lowest power of 0. So the power for each expression, if I see particularly, if I see this, the power of any term varying from highest power, in case of x it is varying from 1 to 0, 1 x to the 1, and this can be expressed properly 1 0 1 into x 0 y 1. So it is varying from the highest power to the lowest 0, and the power of the terms varying from highest power to the lowest power 0 in reverse order. So that means if the first term varying from 1 to 0, the second term will vary from 0 to 1. In this case also, for x plus y whole square, first term varying from 2 1 0, this can be said as x to the power 0. Anything to the power 0 is 1, you know. So 2 1 0 0 1 2. Okay, because y you can assume it is x to the y to the power 0. So y to the 0, y to the power 1, 1 square, x1, x0, and this also varying in this manner. So this we assume the power of the terms varying from highest power to the lowest power 0 in reverse order. If it is one is increasing order, other will be in decreasing order. That is only one concept. And secondly, number of terms is plus 1 to the highest power, isn't it? The number of terms, that means in here your power is highest is 1, so number terms would be plus 1. So 1 plus 1 is 2, 1 and 2. Highest power is 2, so number of terms will be 2 plus 1, 1 2 3, 3 1 2 3 4. Understand? So this can be concluded. So if it is so, then we automatically can write the terms of the further expression if we increase this highest power by to 4, and even if it is not possible to write the coefficient, because coefficient till now we are not following any pattern, we are not described any pattern for this, but only thing we are describing is the term, how the power will vary. So this will definitely from 1 it will reduce by 1 every time, and the reverse order will be this one. Okay, so one part of this we already can understand from this pattern how the power will vary. Now the rest of the thing will remain for the understanding of the coefficient. Okay, so for that what we can do? So for that, if I add one more term on top of it, x plus y whole to the power 0, that will give you 1. So here your maximum power is 0, number of term will be 1, 0 plus 1, 1, and the term will vary from 0 to, because maximum power is 0, so 0 to 0, so the term can be written as only one term of this kind, because x to the power 0, y to the power 0, and this will be value is 1, the whole is 1. So now if I now concentrate on the coefficients only, though for the first line the coefficient is only 1, for the second line coefficient is 1 1, isn't it? For the third the coefficient 1 2 1, for the fourth 1 3 3 1. Now up to this, if I follow the pattern, it is following a triangle, because each arm having equal number of numbers, equal quantity of numbers. There is containing 4, this is containing 4, this is 4. This is formation of a equilateral triangle. So this definitely one thing I can say, this is forming a equilateral triangle with the coefficients of each term respectively. So now if this follows, and this also is following one thing, the side arm is giving 1 every time, okay, and the remaining term how we are forming, if we add these two I will get the below term, if I add these two I am getting the below term, if I add these two I am getting the below term. And moreover, if you want to follow the same rule, for this case also, if nothing is there, I can assume 0 beside this. So 0 plus 1, 1, 1 plus 0, 1. The same thing I can follow here, 0 plus 1. So every time, if nothing is there, I can assume 0. That is possible in mathematics. So to understand then how this 1 is maintaining, so otherwise you can remember this 1 will always carry in the extreme slant arms of the equilateral triangle. So these two arms will form by 1 only. Okay, and the remaining term will form by adding the previous two term, and this will be post, below, middle. Okay, so now if this is the pattern, can you say what could be the coefficients that will come here? Let me take a smaller space and so now if I want to write 1, then follow 1, this 1, 2, 1, the next 1, 1 plus 2, 3, 2 plus 1, 3, 1, then 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and this 1. So now with this pattern I can say the coefficients of this term will maintain this one. So I can put 1 here, I will put 4 here, if we put 6 here, I can put 4 here and put 1 here. Now how do you cross check this? I can cross check this if I directly multiply this x plus y. This is a direct method of getting this. Let me check whether I am getting this formula or not. So x plus y into x cube plus 3x square y plus 3x square y plus y cube. Okay, this is direct method. There is no ambiguity in that. If I multiply this, so x cube, there will be x into x cube, that means x to the power 4. Any other terms is getting x cube, x to the power 4, no. So there will be only one term, so this is matching, x cube, this done, x into this, so this will give x cube y. Any other terms giving x cube y, this and this. So this is 3 plus 1, x into x square y, 3 plus x cube into y, so 4. So 4 is matching, this done. Now x into this, what I am getting? This is, sorry, what I am getting, x into x square y square. Any other terms? This and this, x square y square, 3 plus 3, 6. So if you see, all the terms will definitely match. So that means whatever pattern I am following to get the coefficient will be universal for all the expanded series. Okay, so now if I say what would be my this answer, so if I write the series further to this, I can get the coefficient of this also. So this I am writing 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So this, if I expand, this is x to the highest, this is starting from highest power x to the power 5, then 5 x to the power 4y plus 10 x cube y square, then further 10 x y cube x square y cube, then further 5 x y to the power 4, and at the end y to the power 5. Understood? So this is following the pattern of this triangle, the coefficient following the pattern of this triangle, power following the reverse variation of the power, where for one term, if it is starting from the highest power, it will reduce up to the 0, and the other term simultaneously will vary with this from the 0 to the highest power. This is the third thing. So the coefficient follows this triangle, and this triangle have a specific name which is called Pascal triangle, as per the name of the scientist or the mathematician, you can say, who has invented this pattern. Okay, this is Pascal's triangle. Okay, so but the thing that will restrict us, because this again up to certain term it is okay to find the coefficient, but if in case if we assume something goes very high, then for first term you are doing second, third, fourth, fifth, sixth, you have to go up to 30th row. Is it possible to find like that? How much time you need to solve this? It will be enormous time. So there must be something else which is needed to make it easy, comfortable and very generic. Okay, so for that I need to bring one more concept, concept of factorial. So you have to understand factorial first, but before than that I will describe some of the characteristic of this triangle. The characteristic is that if we follow the terms of this as per the rows given, this is 1. Okay, now the next term is 1 into 11. If I put side by side, it will be 1 into 11. The next term is 11 into 11 gives you 121. If I keep the keep the digits side by side, this will give you 11 into 11 into 11. Okay, this will give 11 into one more 11 will be added. Okay, up to that you will get the digits as it is, but in the from this row, even if you will get all 11 multiplication, you will get 11 to the power 5, but this thing you will not get directly. What you will get? You will get 1 5 0 1 6 1, this result. How it is happening? This is happening because no place will keep more than one digit. So if you want to keep side by side, there is not possible to keep 10 and 10 in one place. So what you have to do? You have to shift the second to the next, this to this. So like that, this is added to 0, give you 1, this is added to 5, will give you. So like that, from the next series, even though it is following the same pattern, you have to adjust somewhat. So this is one kind of pattern. Another kind of pattern that also can be said by seeing the term, it is 1 means 2 to the power 0. Now if you add these two, means you are adding the terms. Here is only one term, so that is 1, which can be calculated by 2 to the power 0, that means 1. This 1 plus 1 2, so that means it gives you by doing 2 to the power 1. 1 plus 2 plus 1 is 4, 2 square, and like that. If we go on adding this, it will follow some pattern of this. There could be one more pattern if we follow the line in a slant way. Means if you see through these lines, specifically in this angle, if you see this all terms if is give you 1, so that means it represents dot heads, because dot heads are always a individual identity, and if you represent in xy coordinate in a 2 plane, this dot heads can be written as 1 1 1 1 1, like that. Next series is counting series. This is counting series where natural count number being counted 1 2 3, like that. This series is following this. So now this can be received if we correlate with the geometry. So this when will add continuously the dot heads 1 2 3 4 5 6, the natural counting will come. This is counting series. This is also can be said a zero simplex. This series also can be named as zero simplex. Okay, the next series is 1 3 5. This is following the triangular pattern. How? The first vertex is started with a 1 point. Okay, the next, if I draw a line, this having 2 points. The next, if I draw a line, it having 3 points. So 1 plus 2 give you 3, 3 plus 3 give you 6, 6 plus next added with one more plus 4 will give you 10. So this is a triangular pattern. So this is specific name is triangular series. Okay, the next having some, and this also called one simplex, this triangular pattern. The next is 1 4. How it is moving? First started with dot, the next is connected with a triangle in a different plane. So this started with giving you a 3D figure. So 1, this 3 will give you 1 plus 3, that is equal to 4. So 1 plus 4. The next bigger triangle where dots will increase in each arm. So each arm will contain 3 dots, and if I extend it, it is 1 plus 4, 4 plus 6 here, it will give you 10. So this, now further this series will move like that. So that will be very difficult. If we go even further, it will very much, up to this is okay. If we follow, this is increased by 3, then it will 4, and like that. The next series, and this is called the quadrahedral. Okay, this is called, sorry, not quadrahedral, this is tetrahedral series. Okay, so that means this is all having, each having a triangle. This phase is a triangle, that is, and they are having 4 phases each time. If I see this is one phase, this is one phase, this is one phase, and the below is one phase, and every time this will go on increasing. So that's why it's a tetrahedral name is given, and this also other way is called 2 simplex. Okay, these are not needed, but as because in a higher study this you can come across if somebody is very much interested pursuing mathematics as his own field of study. If someone is want to do more higher study in mathematics, this kind of things you can come across. So just to give a hint on that, I am just describing these terms, and further this will move 1 2 3 simplex and all that, and this series also follow some geometrical figure in it. Okay, so this much is okay for this series. There is no much interconnection with this knowledge with the binomial theory, so I will not go further into this. The thing I will describe now, it is useful to describe the series if it is going very huge. So that is the term I have taken, the name of it is factorial. Okay, so factorial is a very simple kind of means concept. That concept says multiply all natural numbers till 1. So if I say, if I have to calculate the factorial of a natural number n, where we are saying n is natural, it must be integer, okay, and real, okay, and non-negative. These are the conditions to find the factorial of any natural number. So if I want to find the factorial of a natural number, then this is the result of that factorial. We have to multiply all the consecutive terms till 1. So if we multiply all the terms, this can be represented as factorial n or by this notation. This is one kind of notation, this is another, both are correct, and this we call the factorial of n, where n I have described is a natural, integer, real, and non-negative. Okay, so this is the definition of factorial. For if I say, for example, factorial 5, if I want to calculate, the factorial 5 means 5 into 4 into 3 into 2 into 1. So starting from the number itself, multiplying all the natural numbers till 1. So that is the concept of factorial. Now one basic thing, or you can say the truth or the declaration that has to be made: factorial 0 is equal to 1. That conceptually has to be taken as 1, and this being derived, it's not mathematically derived, that is being logically derived, and scientists have taken factorial 0 is equal to 1, then only they can correlate all other aspects where that factorial is being involved. Okay, and so as factorial 1 also is equal to 1. Okay, so this is the case, and this can be logically proved. How? If I say, for example, factorial 5, it is what? 5 into 4 into 3 into 2 into 1. Factorial 4 is what? 4 into 3 into 2 into 1. 3 is equal to 3 into 2 into 1. Factorial 2 is equal to 2 into 1. Factorial 1 is equal to, let's say, I am writing 1 because starting from the natural number till 1. So this is 1. Now, how will I get factorial 4 from factorial 5? What I will do? Factorial 5 by 5, I will, if I divide factorial 5 by 5, I will get factorial 4. So this will give you factorial 4. Factorial 4 divided by 3 will give you, by 4 will give you factorial 3. And so as 3 divided by 3 will give you factorial 2. So factorial 2 by 2 will give you factorial 1. So factorial 1 divided by 1, it will give you factorial 0. So this is a logical statement. When I am reducing factorial 5 by dividing 5 will give you factorial 4. 4 by giving the next factorial below this, this is giving below this is giving factorial, then definitely factorial by factorial must give you factorial 0. What is the result of this? Factorial 1 is 1, divide 1, it is giving 1. So factorial 0 can logically be taken as 1. Okay. So this is only logically being derived, factorial 0, and this is very useful when we will do the application of factorials to know the factorial 0 is equal to 1. So I'll end up here. In the next, I will correlate this factorial with the terms, with the coefficients of the binomial expressions, that are after the expanding a binomial series, finite series, how the coefficient is related to the factorial, that I will derive. Okay, that I will correlate, and from there a generic expression will come where if I expand a binomial series, how the series will look like, and on that basis any binomial series can be expressed. So be with me, follow the classes. This subject is very much interesting, and if you miss something, you will not able to understand the application or the exercises. So be alert, try to understand the concept that I am trying to make you understand. That is very much important. So thank you for now. Good night.